Well, electric vehicles contribute to carbon reduction and represent a major growth opportunity for the UK, in which the Faraday Battery Challenge is investing. But the supply chain is very complicated with many different organisations involved. Particularly in electrode and cell manufacturing, careful handling of input and processed materials used in battery cells is very important for the quality of the products, as well as the safety and well-being of the people working, making the electrodes and the cells. Now, these processes impact upon the lifetime of performance of the cells and on the potential to use, reuse or recycle them. Traceability is also important for cell manufacturers and the wider supply chain to maintain consistent quality and protect the environment. So this standard is needed to capture a shared view of good practice across all of these areas. Applying it can also save time and it builds a common understanding. So the PAS is a code of practice focused on the health and safety, environmental performance and quality management in the manufacture of battery electrodes and cells. It also provides a handy set of key terms and definitions and references to relevant policies, guidelines and other standards. It addresses the need for quality and traceability of raw materials, not only for the manufacturing of components and cells, but also from an environmental perspective, where the standard covers policy, systems, emissions, waste management from the materials processing and product management. Safety considerations also make up a large part of this PAS. These include the safety systems, hazards and risks, both from the materials and processes. Also talks about incident management. For all these safety considerations, competency and training is a key component. The code of practice is intended for use by battery electrode and cell manufacturers, but it can also be useful for researchers, technology developers, module and pack manufacturers, automotive manufacturers, and indeed the entire supply chain for battery manufacturing. But it's particularly useful for those involved in the materials and the materials processing aspects of manufacturing. So the code of practice has many applications. For example, for supply chain and procurement teams who want to learn about good practice in sourcing and traceability. A second example is for operational managers who need to manage how raw materials and components are treated from product quality, environmental and safety perspectives. Careful control of materials during manufacturing is critical for product quality, but also protects workers from any potential risk to health and prevents release of materials to the environment, whether that be through air, land or water. The final example is R&D and design teams who want to consider the performance safety of battery cells through their life cycle, including recycling and potential second life possibilities. Cell designs impact not only the lifetime of the cells, but also the ability to recycle or reclaim the materials at the end of life. Knowledge around materials value is important to maintain or create an economic viability for recycling processes.